So in today's lesson, we're going to cover a theorem regarding a isosceles triangle. And this theorem states that in an isosceles triangle ABC, the median, bisector, and altitude drawn from the angle made by the two equal sides fall along the same line. Now, to understand this theorem, we need to understand the following three terms: median, bisector, and altitude. So firstly, what's the median? Well, let's take these two triangles we have here. To find the medians of both these triangles, you have to first figure out what is the midpoint of each of the sides. So let's say these dots represent where is the midpoint. Then the median would be the line drawn from each vertex to the opposite side's midpoint. So these three lines represent the median of the purple triangle. Same way, if we find the three midpoints of each side of the blue triangle, and then draw a line from each angle to those midpoints, then we'll get the three medians of the blue triangle. Next is the bisector. So let's say that we want to find the bisector is any line drawn from each vertex that bisects the angle. So let's say for the purple triangle, we want to bisect angle A, then we'll draw a line from the angle to the opposite side, and this would bisect the angle, which means that the two new angles created are going to be equal. Same way, if we bisect angle B of the blue triangle, then we'll end up with two halves of angle B, which of course will be equal since the bisecting line cuts the angle in half. Next is the altitude. The altitude is any line drawn from any of the vertex of the triangle straight down to the opposite side that is perpendicular to the opposite side. So as you can see, let's say for purple triangle, we draw a line from the topmost vertex that is perpendicular to the opposite side, and that means that the angles created are 90 degrees, or right angles. Same way, let's say from the bottom vertex of the blue triangle, we want to draw the altitude, then we draw a perpendicular line from the bottom angle to the opposite side, which will create two right angles. So that's what median, bisector, and altitude is. Now, considering that we have both these triangles, if we draw like the median, the bisector, and altitude all at once on the purple triangle, we'll get this situation. So this is the median of the purple triangle, and this is the median line of the blue triangle, which, if you remember, is the line from the vertex to the midpoint. Now the bisector line of the purple triangle is this one, which basically bisects the angle that it's drawn from, or cuts it in half. And for the blue, it's this one. And next is the altitude. So the altitude of the purple triangle that we drawn earlier was this one, and for the blue triangle, it was this one. So as you can see, all three of these lines, the median, bisector, and altitude, do not fall upon each other. And the theorem is saying that for an isosceles triangle, if these three lines are drawn from the angle that is created from the equal sides, then they will fall directly on each other, so it will be exactly the same line. Now let's look at an example to get a better idea of what this means. So let's have our triangle ABC, and let's say that AB is equal to AC. So that makes it an isosceles triangle since two of the sides are equal. And we're going to try to prove that the median line, the bisector line, and the altitude that are drawn from angle A are all going to fall on the same line. So to show this, the first thing we're going to do is draw the median of our isosceles triangle ABC. So to draw the median, we have to first denote what's the midpoint. So let's say D is the midpoint of side BC, and we're going to draw the median line from A to D. And now that we know this is the median, we want to also prove that this is also the bisector and the altitude of this triangle. And that'll show that the theorem holds true. So beginning with our proof, we already know that AB and AC are equal, and since we said earlier, we're going to make D our midpoint of BC, which makes AD the median. So keeping all this in mind, we know that BD has to be equal to CD because we've already said that D is our midpoint. Also, we know that angle ABC has to be equal to angle ACB because ABC is a isosceles triangle. So now with that information, we can now say that by side angle side, triangle ABD is congruent to triangle ACD because side AB and AC are equal, side BD and CD are equal, and the angle between them is also equal, proving that these two triangles are congruent. So because they're congruent, we can now say that the angle BAD is equal to angle CAD. And if those two are equal, then that means that the line AD has bisected angle BAC. So that makes AD the bisecting line of angle A. So now we've proven that AD is a bisecting line, and all that's left to do is to prove that AD is also the altitude. Well, so you can see, because we said earlier that triangle ABD is congruent to triangle ACD, we know that angle ADB, which is right here, it has to be equal to angle ADC, which is right here. And also, this line, BDC, is a straight line, so it's 180 degrees. So the only way this angle and this angle can be equal and also result to a 180 degree straight line is if they're both 90 degrees. So since we have two 90 degrees here, then that proves that line AD is the altitude of ABC. Thus, that shows that in an isosceles triangle, the median, the bisector, and the altitude lie on the same line.